So in this problem, we have Greg Cribb's mom is now in a car. And she's starting at rest. And my question is, how far will she go in 10 seconds? That is the question. But we're going to need some information to find that out. Here's what we know so far. We know that Greg Cribb's mom and the car together have a mass of 800 kilograms. We know that the engine of the car produces a thrust of 5,000 newtons. And we know that the mu, the coefficient of friction, is 0.187. So the first thing we got to do in every problem is scratch our ear. And then forces, that's right. Label all the forces. So let's label them. We already got the thrust force, I already labeled that one. What else we got?
Gravity.
Graviton! Which is it?
7,800.
Oh, you already calculated that. What was it? 7,850? 40 newtons.
Yeah.
7840 newtons. By the way, isn't that 7840 also the normal? They have to be equal in this case. Unless it's falling through the earth or being launched up off the earth, those two have to cancel, right? Unless there's an acceleration up or down, it have to be the same. What else do we know? Well, we know there's a friction force, right? Now, some problems might actually want to work in air resistance as well, but the problem doesn't mention air resistance, so we'll ignore that. So what can we find next?
You can find the friction force.
We can find the friction force, exactly, can't we? What is the friction force? Well, the formula is, that's the formula, y'all.
1,466.
We take the mu times the normal we just found, which in this case, not always. I have to warn you about something. The normal and the weight, almost this entire chapter, well, except for an elevator problem, are going to be the same. But you've got to really resist the urge to think of them as the same thing. They're different things. When you start doing tilted surfaces, inclined planes we call them, in the next chapter, it'll make a big difference. So normal and weight aren't the same, but they will be a lot of times in this chapter. If it's on a flat surface that's not accelerating up or down, they're the same. Okay? And what did you say that number came out to?
1466.
So we know that this is 1466 newtons. All right. So we know the up-down cancel. Do the right-left cancel? No. Which one wins?
Thrust.
Thrust. By how much?
3,533.
So what did you, that number that Max just told me is what? It is the net force. What did you say that was, Max?
3,533.
And you got that by just subtracting these two numbers. This one's that much bigger than
Mr.
that.
Higginbotham, please call 0.
What numbers?
34 newtons. You see where we're going with this now? Now that you have a net force, what can you always find next?
Acceleration.
Acceleration. So F net equals ma, so 3534 equals ma, and m is
Or 800.
800. We're starting to do enough problems that you're beginning to disconnect m from weight now. You see the difference? So now we divide, so basically divide that by 800, and a is
4.4.
4.4 meters per
Second
second squared. And what was the question? How far will she go from rest in 10 seconds? That is an acceleration problem like we did before. Which formula is going to give us distance,
Vit plus half fast.
vit plus half f squared. Initial velocity is 0, so we'll skip the vit. The 1/2 at, and the 10 is the t, but we're going to square that. So that turns out to be what, 220? So in 10 seconds, she'll go 220 meters. Boom. There you go. Oh, fine, just leave that camera running forever, Booger.